the relationship between a quadratic function and many-to-one relation. So first of all, we are going to look at quadratic function. Okay, there are a lot of names that you are going to encounter later on. First, you are going to see what is a quadratic expression. We have quadratic function, so it's two terms that is totally different. So if you look at the conversation given over here, what is the difference between a quadratic expression and a quadratic function? So what do you think? Do you have any idea what is the difference of them? From the word quadratic expression and quadratic function. Can you give me a quadratic expression? Anyone? Quadratic expression. You have learned a lot of quadratic expression, isn't it? For example, x squared plus 2x plus any number that you like?
4, 5.
Okay, 4 or 5. Okay, so this is a quadratic expression. The difference in between expression and function is that they just add on another fx in front. Okay, so when the fx is added, this is called a quadratic function. Okay, so why is it so? Later on, we are going to see further. So you look at the given answer from the teacher. A quadratic expression is written in the form of ax squared plus bx plus c, whereas the quadratic function is written in the form of fx is equal to ax squared plus bx plus c. So the only difference is the addition of this part here. Okay, to make you understand further regarding the function, why suddenly it becomes a function like this? Because there are certain, theoretical part that makes it a function. So I got it from your additional maths book that you are going to see later on. I'm not sure whether your teacher have entered into this or not. So this is explaining function by graphical representation and notation here. So you look at the graph here. This graph is y equal to 2x plus 1. Okay, the relation between the value of 1 on the x-axis here, this one here, and 3 on the y-axis can be written as y is mapped on 3. Okay, y is mapped to 3. This indicates that the 1 is the first element and 3 is the last element. Okay, in this case, we can say that 1 is mapped to 3, similar to the rest. The 3 here is mapped to 7. And then this one, the 5 here, is mapped to 11, and so on. So the relation of the mapping from x to the y can be represented using the arrow diagram like this. So this is 1, 3, 3, 7, 5, 11, right? So 1 is mapped to 3, 3 is mapped to 7, 5 is mapped to 11. So the mapping of this, we can represent it as a function. Okay, that is why we call it function. So later on in MS, you are going to see this further. Okay. Now we look at the stimulation 3 here, the aim to recognize quadratic function as many-to-one relation. You have learned how many types of relation previously in Form 2, do you remember?
Yes.
How many types?
4.
4 types, very good. What is the first type?
One-to-one.
One-to-one relation. Second type?
One-to-many.
One-to-many. After that?
Many-to-one.
Many-to-one. And last one?
Many-to-many.
Yes, very good. Wow, you all can remember that. That is great. Okay, so remember this, for a quadratic function, the y is equal to function x. Okay, remember just now like we have y equal to 2x plus 1, so we can represent the y as fx. Okay, that is the meaning over here. Now, if you look at the 3 quadratic functions that we have over here, we look at the first one here first. Fx is equal to x squared minus 3x. So this is the graph here. Okay, now they use a horizontal line here to plot 2 points that intersect on the graph. So the number of points of intersection, we will have 2 points. This horizontal line is up to you. You can put it anywhere. Okay, the purpose that we are doing this mind simulation over here is to recognize the quadratic function as many-to-one relation. So they take this because they can get a precise value from there. That is -1. Can you see that? And then this part over here is a 4. So the coordinate that we have for this one is actually negative 1, 4. This is the one. That is the points of intersection. And then this point over here is 4, 4. So the number of points of intersection that we have when you draw a horizontal line that cuts through the function, there are 2 intersecting points. Okay, now in B here, we look at this function here, negative x squared plus 4x plus 1. So this is the function. Okay, if I draw a straight line, a horizontal line that cut through this function, for example, this one here. Can you tell me how many number of points of intersection for this?
2.
2, right?
2.
Yes, this is the 2 here. Okay, so what is the point of intersection for this one here?
0 and 4, right?
Is 0, 1. 0 and 4 is the x. I'm asking for the coordinate here. Okay, 0, 1, right? Okay, and then this part will be 4, 1.
4,
Yes, 4, 1.
4, 1.
Right. So now, for the third question, seems like you are getting more understanding about this one already. I'm going to ask your friend here to answer me. So I don't want everybody to answer here. So for this graph, x squared minus 3x plus 2, this is the one. Okay. Now I'm going to choose the horizontal line here. I'm going to draw it up here. Okay, let me see. Damia Farhana, you are there, right? Can you tell me how many number of points of intersection?
2, madam.
Yes, very good. 2 means you are listening to me just now. Okay, the first point of intersection, can you give me the coordinate here? Felix. This one.
Negative 1, 6.
Yes, very good. Negative 1, 6. Okay, after that, I want the coordinate of the next one. Let me see. Just now is Dania. Dayang Nourish, can you give me the next point here for this one?
1, 4.
See carefully.
6, 4.
You have to mention the coordinate of x first. Coordinate x followed by
4,
coordinate.
6.
Yes, very good. 4, 6. So make sure you know
Sorry,
how to
madam.
find the point. Yeah? Are you nervous?
Yes, madam.
No problem. Okay, let us move on. So we haven't found out the quadratic function is many-to-one relation yet. So how are we going to determine that? We are going to determine that based on the coordinate that we have. Okay, so for example, this one, the points of the intersection is 4, 4. You see, for the point on the Cartesian plan, the x coordinate, how come I have a, sorry, let me see. Oh, okay. X coordinate is the object and the y coordinate is the image. So you see, 4 to 4, we can draw the diagram like this. And then negative 1 to 4, this is negative 1 to 4. So you remember when you see this kind of diagram here, it means this is a many-to-one relation. Same with the rest, you can see 0 to 1, 4 to 1. There are 2 objects and 1 image. So this is also many-to-one relation. Same with the third one, negative 1, 6, 4, 6. Only 1 image, so this is many-to-one relation. So you got to memorize, for a quadratic function, it is a many-to-one relation. Okay? So you see this part here, all quadratic functions have the same image for 2 different objects. So just remember this. Let us move on. Okay, what is the shape of the graph of a quadratic function? In the first lesson, I've already told you the shape, right? Whenever we have the value of a that is greater than 0, we will have a U shape like this. The value of a, which is this part here. And when the value of a is less than 0, we will have a N shape like this. Okay, so there are only 2 shapes of the graph, and the value of a determines the shape of the graph. So this is a repetition. Hope you remember this already. We move on. Okay, from the shape of the graph over there, we are going to determine what is the maximum or minimum point of a quadratic function. So if we look at the graph here, can you tell me this graph, what is the value of a?
Negative.
Yes, negative, correct. And then it is less than 0.
Less than 0.
Yes, less than 0. So you remember this. Okay. Whenever we have A is less than 0, you see this point is on top of it. Do we call it a maximum or a minimum point?
Maximum.
Very good. When it is on top, it is called maximum point. Okay. So this description on the right over here, it just explain whatever we have on the left lah, for the sketch of the graph of a quadratic function with the value of A is less than 0. Y1 is the highest values. This one, Y1. And coordinate the X1 over here is the corresponding value of Y1. So the point X1, Y1 is known as the maximum point. Okay, when it is like this, so you know that the value of the value of A is greater than 0. So the part that is at the bottom of this one, we will call it what point? The opposite, that will be the minimum point. Okay, so the corresponding value for Y, the X1, X2, Y2 is over here. This is the minimum point. Okay, now after you have learned the maximum and minimum point, there's one more thing that you are going to identify, that is the axis of symmetry. So this one is, you just remember this part. For a quadratic function, ax squared plus bx plus c, the maximum point obtained when a is less than 0. Okay, you remember this. Sometimes you cannot see the graph. They only tell you about this. So when a is less than 0, you will have what point? You have to understand yourself already. A less than 0 meaning is a n-shaped graph. So we will have maximum point. You have to think about it. Okay, next one. What is the axis of symmetry of the graph of a quadratic function? So hopefully you still remember what does it mean by axis of symmetry. Do you remember the axis of symmetry? Yes, It is a straight line that divides a geometrical shape or an object into two parts of the same size and shape. For example, I have an equilateral triangle. Can you tell me how many axes of symmetry do I have for the equilateral triangle?
3.
1.
3, because I said equilateral, right? All is having the same size here. So I will have 1, 2, 3 axes of symmetry. Okay, now when we enter the graph of quadratic function, the U shape, how many axes of symmetry do we have?
1.
Yes, this is the one, right? Only one. Same when we have the N shape, also only one axis of symmetry. Okay, we look at the diagram that we have here. So if you look at the axis of symmetry of the graph, we will have maximum point and minimum point that falls on the same axis. Just now we learned the maximum point, right? And the minimum point, right? So the maximum and minimum point will fall on the axis of symmetry. So next time you are going to determine where is the axis of symmetry, directly you can find out what is the minimum point already. Okay, let's see. This one is a smart mind. And then this equation is very useful. The equation of the axis of symmetry for a quadratic function is x equal to negative b over 2a. So later on you are going to apply from the function given, then you are going to substitute the value of b and a into it to get the axis of symmetry. Okay, for example, if this graph over here, I'm going to draw it like this, I add on. The value is 2 here and this is 5. Can you tell me what is the equation of the axis of symmetry? Equation of axis of symmetry.
X equals negative.
X equal to
1/4.
X is equal to 2 because it cut through the number 2 here on the x-axis. Okay, don't worry, I'm going to enter further so that you understand on how to draw and recognize the axis of symmetry of the graph of a quadratic function. So we are going to learn to find out and recognize it. Okay, another tree graph. So they ask you to write the equation of the axis of symmetry as in A. This one. You see, the A, they draw the axis of symmetry readily for you. The axis of symmetry, it cuts through the number 1 on the x-axis. So the equation of the axis of symmetry, you just need to write down x is equal to 1 like this. Okay, now we look at the second function here. This is the graph. Okay, can you determine where is the line of the axis of symmetry?
-1.
It's in the middle here, right? -1. So how do we come up with the equation of the axis of symmetry?
X equals to
X
-1.
equals to -1.
Very good. Now the next one, so this is -2x squared plus 4x plus 2. So see, the value of A is less than 0, right? So you will have an N-shaped graph or set-face graph. Okay, so where is the line of axis of symmetry there?
1.
Very good, 1. Because it divides equally, both sides, they divide equally. Okay, so you can find out the equation of the axis of symmetry already, right?
Yeah.
Okay, what is the answer? X equal to?
X
X equals to 1.
Yes. So when you go through all the axes of symmetry, do you have an equation that starts with y or not? When you go through the axis of symmetry for quadratic function, do you have equation that starts with y?
No.
No, and never, because we won't have the axis of symmetry that cuts through the y-axis like this, because all our function is just a u-shape and n-shape only. So your axis of symmetry will always cut on the x-axis. That's why you see all the value of the axis of symmetry here. The equations start with x. Okay, so you remember that, huh? I think I have some more else here. So now we need to discuss this part here. What is the relationship between the axis of symmetry of the graph of a quadratic function and the y-axis? So if you look at the first graph here, this is the axis of symmetry. What is the relationship with the y-axis here? Can you guess?
It's a vertical line.
It's a vertical line? Not really correct.
Parallel to the y-axis.
Yes, very good. They are parallel. So this axis of symmetry is parallel to the y-axis. Okay, you can see all the axes of symmetry that we have. This one, it is also parallel to the y-axis. Okay, everything is parallel here for the y-axis and axis of symmetry. Now we look at the second discussion here. What is the relationship between the axis of symmetry of the graph of a quadratic function? So this is the one, and the maximum or minimum point. So we look at the first graph again. This one is maximum or minimum point? Minimum, right? Okay. What about this one? Minimum or maximum? Minimum, good. This one, minimum or maximum?
Maximum.
Okay, this one is maximum. Now, they want you to find the relationship between the axis of symmetry and the minimum point, or axis of symmetry and the maximum point. Can you tell me what is the relationship?
The axis of symmetry always goes past through the maximum or minimum point.
Wow, great. Who is that? Hazim, is it?
Yes.
Great. Yes, the axis of symmetry over here is always passed through the minimum point. You see, it passed through the minimum point, it passed through the minimum point. Okay, so that is two of the relationship that we found out here from this activity. So you just remember that here, the axis of symmetry of the graph of a quadratic function is parallel to the y-axis, the first one that we found out, and it passes through the maximum or minimum point. Okay, I think we are reaching almost at the end here, so we look at the next slide. In general, each graph of quadratic function has one axis of symmetry, which passes through the maximum or minimum point. So if this is the axis of symmetry, the minimum point is hk. then you can determine the axis of symmetry already. That is x equal to h. We get the value of the axis from the value of the minimum point. Same with the maximum point. When you are given the maximum point mn, so you can find out the axis of symmetry whereby the value of x is equal to the m given over here. Now, if I change the maximum point becomes 10, 2. Okay, I'm going to call the name again. Let's see who is available here. Hasha Hazwani, are you there?
Yes.
Okay, Hasha, can you tell me what is the equation of the axis of symmetry based on this maximum point?
X equals to 10.
Yes, very good.